these rule logarithms. You have to be able to go both ways here. In other words, you have to be able to go from left to right, which is called expansion, and you have to be able to go from right to left, which is called compression.
All right.
When you take the log of two things that are being multiplied, you add the logs of each. If you take the log of two things that are being divided, you subtract the logs. It's much like exponents. You're always doing one level less. And finally, the third one is the log of a to the b power equals b times log of a. Okay? So, for sure, memorize these three, and because you have to use them on all kinds of problems like this. Now, let me state one thing. These are true only if the bases are the same. In other words, if I have log base 3 and log base 4, I can't do that. I can't say that it's log of AB. Only if the bases are the same for all of them can I do that. All right, so this problem here, we've got, it doesn't specify a base, so we're to presume it's base 10.
Just because that's what it usually is?
No, you either have a base specified. If it's not specified, it's automatically 10. And if it says ln, natural log, then it's automatically E, base E.
Okay.
Those are the only three situations. Since it's not specified here, we know it's base 10.
All right.
If I look at rule number 3, what's the first thing I can do to compress this thing?
Combined two A's.
No, let's just rule 3. Let's make sure we go this way. In other words, we're looking at some number times the log of 3. What we're looking at over here, 5 log of 3, is b log of a. So compress it into the log of a to the b power.
Okay, so it'd be log 3 to the 5th power.
Correct. So that's the first thing we can do. Make that say this. Plus log 2. Now let's compress those two things where we have two log functions being added. Therefore, that's equal to a single log function of what?
So I have to do 2.
Here you're going to do the opposite of rule 1. In other words, rule 1 says the log of a plus the log of b is equal to the log of a times b.
Okay.
So here we have the log of 3 to the 5th plus the log of 2. So what single log function is that going to be?
Well, are you just adding them then?
Multiplying. In other words, if they're separated and you put it back together again, you multiply them. So it's 3 to the 5th times 2.
So it'd be log 5 to the 5th power?
No, log of...
Or 6, sorry.
This is... simplify your answer. They don't want a number here. What they want is a simplified expression. Okay, well, what is that? What is 3 to the 5th power times 2? You have a calculator?
Yeah.
3 to the 4th is 81 times 4 times 8. So what's 81 times 8?
It's 486.
There's your answer.
Okay.
Let's see what kind of form it wants it in here.
I wrote that answer.
Yeah.
I can just delete all that.
So let's see. I can just say the log of, what was the number?
486.
I don't think that's right. Should be 81 times 6. Okay, that is right. 81 times 6. Yeah, that's 486. Okay, sorry. That should work. See why I didn't need to specify base 10?
Yeah.
Okay. Now let's have a look at 6. Expand the logarithm, simplify if possible.
Oh, we can't redo that.
We can't?
No, we can't.
Okay. Notice that division is taking place. So if I expand that, what would it be?
Oh, is that a 2? I can't really read that. What does it say?
It says log base 2 of r over s. So if I expanded that using rule 2, what would it be? In other words, there's rule 2 is the log of a divided by b.
So it'd be log r minus log s.
Yeah. With the base. With the base. Yeah. In other words, it's got to be the same base. So that's the E is the correct answer.
Okay.
Okay. Change of base formula. Not a lot that you got to memorize with logs, but boy, the stuff you do memorize, you want to memorize. If I have the log of, let's say, base 7, I want the log of 4 base 7. The way I remember the change of base formula is it's the log of the big number. By big, I don't mean size, I mean the bigger number, 4, divided by the log of the little number. You know what I mean by big and little?
Yeah.
Okay. Or you could say the log of the number on the right divided by the log of the number on the left. Maybe that's a better way. Now, what base? Whatever base you want. These ratios, in other words, this is a true statement. All of these ratios are the same. This is base 10, this is base 9, this is base E.
Alright.
The key for change of base is regardless of what the base is, here the base is 7, you just take the log of the number on the right, divide by the log of the number on the left. And you can put whatever base you want on these, as long as you're talking about the ratio. In other words, it's not true that natural log of 4 is equal to log of 4. But natural log of 4 divided by natural log of 7 is the same ratio as log of 4 divided by log of 7. So, what's this going to be equal to?
Log, is that 13?
Yeah, it's 13 is the little number, 25 is the big number.
Then it would be log 13 over log
The
25.
other way.
Oh, I thought the little number. Oh, so the
The
right.
number on the
goes
right goes on top.
Alright,
That's
so
the way
log
to remember.
25.
When I say big and little, I mean the size of that 25 is bigger than the size of the 13. So it's the big over the little. But not the thing wrong with that explanation is that you might interpret big as being the size of the number. Well, certainly 25 is bigger than 13. But in our last case, notice that the 4 was the big.
Right.
It's the number on the right divided by the number on the left, with logs around both. So this has to be the log of 25 divided by the log of 13.
And that's all you have to write for that?
No, we need to, it says round it to 3 decimal places, so let me pull that up, and you can do it on your calculator if you want, or I'll do it on Wolfram Alpha here. Log of 25 divided by the log of 13. So there's the number. It says round to 3 decimal places. What should I put?
1.255.
1.255, yeah.
So that would be log 22 over log 13. And then to find this answer, are you just doing 22 divided by 13 basically?
No. No, you're doing the, watch what it gives back as the feedback. It's the log of 22 divided by the log of 13. You can get that,
but I can still type
you can get that number out of your calculator, the log of 22.
Alright,
You have to divide it by the log of 13. Notice that that is not the same as the log of 22 divided by 13. The log of, in other words, if I said what was the log of 22 divided by 13, that'd be the same as, if I said what is this, notice this is quite different. But this would be equal to the log of 22 minus the log of 13. Whereas our problem is the log base 13 of 22. In other words, we merely have a log that's not a common base. It's base 13. So since you don't have base 13 on your calculator only has 2 log keys, right? Which calculator do you have? The TI?
I have 83
Okay,
plus.
so yeah, you have a natural log key and you have a common log key. And that's it. If you were asked to evaluate this log base 13 of 22, you would need to know the change of base formula. Because you would need to know that in order to get this off of your calculator, you got to do this. You can get that from your calculator. You can also get that from your calculator.
Okay.
Now the answer that Wolfram Alpha gave us was 1.205. I have to keep my keyboard away from my cursor. My mouse likes to go crazy when I have them too close to one another. I think it's because they're both wireless.
Oh. Alright, so this one's going to be log 16 over log 24.
Really like beating a dead horse. Man, once we can do two of them, we got to be able to do all of them when they're like this. Yeah. When the only thing they're doing is changing the numbers. So 0.872. Uh-oh, what did I do? Did I go too fast? The log of 16 divided by the log of 14. I divided it by the log of 24. What's that round to?
1.051.
Okay. I'll bet if you wouldn't have needed me on these if you'd have known how to do the first one, huh?
Yeah.
In fact, all I have to do here, uh-oh, my cursor's starting to jump around. Maybe I can get this in before I have, if I have to reboot, I might have to reboot on a moment's notice.
So 1.188.
Let's see, which arrow, the single arrow or the double arrow?
It doesn't really matter, I don't think.
Okay. Wow, did we switch assignments?
No.
This is question 11 following questions 7, 8, 9, and 10 that were all log questions?
Yeah.
Oh, I know why. Okay, I see why now. I didn't see this log over here. All right, so that's right. pH scale is a log scale.
Isn't P A and H is B basically?
What did you say?
Isn't P A and H is B? Just like what we've been doing.
Well, let's look. Let's see. Use the formula pH equals P capital H equals minus the log of H. What's that plus sign mean?
It's going to be positive?
Oh, no, I see. H plus is the hydrogen ion concentration. And in this case, it's 2.4 times 10 to the minus 11. So, if P comma H is equal to minus the log of H plus, and H plus is 2.4 times 10 to the minus 11, then the pH is this number. Now, let's talk about this for a second. So what can I do with that minus sign?
I don't know. Because if you do all the numbers, you get 2.
That's like a -1. So if I take that and stick it up here, I can do that, right? Dealing with logs. In other words, that's the same thing right there.
Yeah.
Now I can multiply the -1 times the -11, and so the pH is going to be the log of 2.4 times 10 to the 11th. Let me do that on Wolfram Alpha, although you might want to make sure you know how to do this one on your calculator, because it's got scientific notation.
You just have to close the parentheses, right?
You have to do what?
You just have to put the numbers in parentheses, right?
I'm not sure. I'm not sure I've ever had to do scientific notation on a calculator. We know that it's 2.4 with 11 zeros after it. So you don't need to put it in as scientific notation. In fact, I'll put it in as regular notation here, and then we'll play with what scientific notation would be. So I want the log of 2, 4, 0, 0. In fact, let's leave out the 4, 0, 0, 0, 0, 0, 0. We want 11 spaces to the right of the 2. That's 1, 3 zeros, 3 zeros, 3 zeros. So I guess the answer is 28 point what?
All right.
It says round to the nearest tenth? Yeah. 28.5. All right, I was wondering if I had to do that. Now, let's go back and rethink this. So, I was correct when I moved the -1 to up to there. But what I didn't do, in other words, what I really need to do, let's leave the minus down here for a moment. And notice that we have the log of a product. 2.4 times 10 to the -11th. So if I expand that, then I have minus brackets the log of 2.4 plus the log of 10 to the -11th. Okay, you with me?
Yeah.
Now, that minus sign, I got to apply to both of these. So this becomes to the -1, and this becomes to the +11.
Oh, okay.
Now I got two different things, and now let's look up what the answer is. That'd be the log of
2.4 to the power 1, or -1.
Yeah, hold on a moment here. Let's see. 10 to the 11th is a 1 followed by 11 zeros. There's 3, 3, 3, 2. Okay, so that's 10 to the 11th plus the log of 2.4. Ooh, 2.4 to the minus 1, which is the log of 1 divided by 2.4. Like that. Now let me hit enter so we can see, make sure we got the right thing. It appears we have the right thing, and that's what their error message told us, is that we need to do this. So this should be right. What is that, 24.5?
Yeah.
Just off by a digit. Ah!
Would it be 24.45? No.
No, it acts like it wants me to find these two logs all by themselves and then apply the negative sign to those numbers. So let's do it that way. I can't understand why that would give us a different answer. So let's see. We want the log of, well, let's just make that 10 to the minus 11, which has got to be minus 11, right? There's the log of 10 raised to the minus 11th power is that plus the log of 2.4.
To the negative 1 power.
No, let's do it the way they're suggesting we do it, which is to calculate this part right here, the part that's inside the parentheses. So I'm going to take the log of 2.4 and add to it the log of 10 to the minus 11th. Well, I know that's minus 11, but that's okay. I'm still going to do it like that. Let's see what they give us. Okay, that's the sum, but then we need to take the negative of that. No, that's what I did last time. They didn't like my answer. In other words, look what they're telling us to do. Use the product rule to write that as the negative of the log of 2.4 plus the log of 10 to the minus 11th. Well, if that's equal to minus 24.45, and then I apply the minus sign to it, it turns into 24.45. Or 24.5 when rounding up. It says round to the nearest tenth, right? Round to the nearest tenth as needed. Then calculate the two logarithms and simplify. Well, I calculated that logarithm. I calculated that logarithm and added it, and then I stuck a negative sign in there.
Is it just because we didn't put it in as a negative?
It's not going to be a negative. In other words, when I did it on Wolfram Alpha, I left it as a positive. Yeah. See, that's the log of 10 to the minus 11th plus the log of 2.4. That's what I've got right here. And that gives me a negative number, in which case I apply this negative sign to that. And I should get the answer that I've already put in and I didn't like, 24.5.
Yeah, that doesn't make any sense.
I'm pretty sure.
Do you have another session you have to get to? Because it's past.
I'm sorry, I completely forgot. Spaced it out. Let me leave that.
I'll
Hit save.
ask my teacher tomorrow.
Yeah, I'm a little.
Yes, please.
Yeah. Okay. All right. Yeah, I don't know what's going on with that problem there. I don't see what mistake I made. But anyway, I will talk to you next time, Tucker.
All right, thank
You're
you.
welcome. Bye-bye.
Have a good one.
You too.